Using the property of determinants and without expanding, we have to prove this. This should be proved without usual expansion of the determinant. By using property of determinant, we have to prove this one. So let us see what is the properties of determinant first. There are 6 properties under the determinants. The first property, let us see, the value of determinant remains unchanged if its rows and columns are interchanged. So the rows and columns are interchanged is the definition of transpose of a matrix. The determinant value of the given matrix and the determinant value of the transpose of a matrix will be same. That is what the first property is. Determinant of A is equal to determinant of A dash. That A dash is nothing but transpose of A, if A is the square matrix. The second property, if any 2 rows or column of a determinant are interchanged, then the sign of determinant changes. That is, suppose delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. Just I am interchanging the first row by third row and third row by first row. My determinant will be like this. First row is changed as third row and third row is replaced by first row. When you find the determinant of this, delta 1 will be minus delta. That is what they are coming to say from this property. In the previous property, completely the rows are changed by column. That is what? The transpose of a matrix. Here it is just any 2 row or any 2 columns are interchanged. The third property, if any 2 rows or column of a determinant are identical, that is, all corresponding elements are same, then the value of determinant is 0. For example, delta is equal to 3, 2, 3. The first row is same and the last row is same. Any 2 rows of the determinant are same, then the determinant value is equal to 0. The next property, property 4, if each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. Suppose we are taking a determinant A1, B1, C1 and A2, B2, C2, A3, B3, C3. What they are said, each element of a row of a determinant is multiplied by a constant. Suppose I am multiplying here with constant k. See, KA1, KB1, KC1. A row is multiplied by a constant k. Then the value of this determinant will be k into the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. This is what they are coming to say. It looks like this. So KA1, KB1, KC1, A2, B2, C2, A3, B3, C3 is equal to K into the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. So from this property, what they are coming to say, by this property we can take out any common factor from any one row or any one column of a given determinant. Suppose this is a determinant, we can take this common factor out from the determinant and we can write like this. Property 5. Next property, if some or all elements of a row or column of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. Let's see this by an example. See here, the elements of the row is expressed as sum of two terms a1 plus lambda 1. If suppose it is like this, then the determinant can be expressed as sum of two determinants. So I have written like a1 b1 c1 as a one determinant plus lambda 1 b1 c1, lambda 2 b2 c2, lambda 3 b3 c3. So we have split it and written the determinant as a sum of two determinants. This is what the property 5 says. The last property, if to each element of any row or column of a determinant, the equimultiples of corresponding elements of other row or column are added, then the value of determinant remains the same. That is, the value of determinant remains same if we apply the operation like R1 tends to R1 plus KR2. For example, I am saying it. It is written Ri tends to Ri plus KRJ, or column similarly. With an example we can see it. What they are coming to say, to each element of any row. See here, the determinant is here. To this row, to each element of this row, what they have done? The equimultiple of corresponding elements of other rows. What they have multiplied here? K C1. It has been multiplied or added. They are added to the first row. Here the C1, C2, C3 are multiplied by a constant, and that is being added to our first row. If suppose this operation is done to our determinant, then the value of the determinant remains the same, they have said. There will be no change in the determinant value. How it is so? Let us see the verification. Here is a delta 1, a1 plus kc1 is given. Now we are taking this matrix and we are going to show the value remains same as the delta. Now the delta 1 is equal to, we are splitting and writing by using the before property. We can split and write it. So a1, a2, a3, b1, b2, b3, c1, c2, c3 plus kc1 in such a way. Now this determinant can be written like k into determinant of c1, c2, c3, b1, b2, b3, c1, c2, c3. This is also one of the property. Here the two rows are similar. If so, two rows are identical, then the value of the determinant is equal to 0. We have seen in one of the property. So this will become 0. K into 0 will become 0. So delta plus 0 will be again delta. The first question, determinant of x a, x plus a, y b, y plus b, z c, z plus c. We have to prove the value of this determinant equal to 0. So first thing, we'll write the given matrix. We can do this problem in two ways. First thing is, we are going to add these two columns, x plus a, y plus b, z plus c, and we are going to write it in the first column. This is one of the property. When two rows or two columns are added, there won't be any change in the determinant value. So I'm just adding it. First column and the third column is similar. Therefore, the determinant value is equal to 0 by the property. So the another method is, now this can be written by splitting and writing. By the last property, I can write it, the determinant as x a x, y b y, z c z plus the determinant x y z a b c a b c. Now from this two determinant, here the first column and the second column are identical. Therefore the determinant value is 0. And here also the second column and the third column is identical. Therefore the determinant value is 0. 0 plus 0 equal to 0. The next question. Determinant of a minus b, b minus c, c minus a, b minus c, c minus a minus b, c minus a minus b, b minus c is equal to 0. So the given determinant is here. Now I am going to make one of the row or column completely 0, so that when I find the determinant value, the determinant value will become 0. So here on adding R1, R2 and R3, it will be, make it a minus b plus b minus c plus c minus a will be 0. I am going to apply the operation. R1 tends to R1 plus R2 plus R3. So when I do so, what happens? A minus b plus b minus c plus c minus a. This is what happened in all the things. So it will get cancelled. Minus b plus b minus c plus c, a minus a will get cancelled. The second term also, b minus c plus c minus a minus b. B minus b will get cancelled. Minus c plus c will get cancelled. Minus a plus a will get cancelled. Again here on adding these three terms, c and minus c will get cancelled. Minus a plus a will get cancelled. Minus b plus b will get cancelled. So that your first row will be 0, 0, and the rest of the thing will be as it is: b minus c, c minus a minus b, and c minus a minus b, b minus c. Or else you can do it column wise also. C1 tends to C1 plus C2 plus C3. If I do so, a minus b plus b minus c plus c minus a, b minus c plus c minus a plus a minus b, c minus a plus a minus b plus b minus c. Again it will get cancelled. So your first column will become 0. If suppose this is getting 0, the value of the determinant will be sure 0. Even if I do it row wise, my first row is completely 0. When I take the determinant values, the value of the determinant will be 0. The next problem, determinant 2, 7, 65, 3, 8, 75, 5, 9, 86 is equal to 0 we have to prove. So let us take the determinant. The first operation I am doing here is C3 tends to C3 minus C1. The column 3 is subtracted from the column 1. So C3 minus C1 is 65 minus 2, that is 63. 75 minus 3, that is 72. 86 minus 5, 81. Now these are all the common multiple of 9. This 63 can be written as 7 into 9. 72 can be written as 8 into 9. And 81 can be written as 9 into 9. Therefore, 9 is the common multiple. I will take 9 out from this determinant. This is also one of the property. Therefore, 2, 3, 5, 7, 8, 9, 7, 8, 9. The two column are identical. Therefore, the determinant value is equal to 0. Next problem. The determinant 1 BC A into B plus C, 1 BCA B into C plus A, 1 AB C into A plus B. We have to make it 0. The first thing what I am going to do is C3. This column I am going to add with the column 2. C3 tends to C3 plus C2. So what happens if I do so? Here I have AB plus AC, here BC. So AB plus AC plus BC. Again here BC plus BA BC plus BA plus CA. Next, AB plus CA plus CB. CA plus CB plus BA. Now all these terms are AB plus AC plus BC, AB plus BC plus CA. So all these are same. Therefore you can take this element as common. So I'll write this out. So that 1, 1, 1, 1, 1, 1. These two columns are having the identity elements. Therefore the determinant value is same. The next problem, determinant B plus C, Q plus R, Y plus Z, C plus A, R plus B, Z plus X, A plus B, BP plus Q, X plus Y equal to 2 into determinant A, P, X, B, Q, Y, C, R, Z. This is what we have to prove. Taking LHS, I'll prove your RHS. Now, the first thing what I'm going to do is, I'm going to add the elements. Like R1 is written as R1 plus R2 plus R3. You cannot add like this. Suppose I am doing it, all the elements will get mingled. Q, R, Y plus Z. But here what we have to show is A, P, X, B, Q in such a way. So that I am going to add it by row wise. R1 tends to R1 plus R2 plus R3. So on doing that operation, R1 tends to R1 plus R2 plus R3, I am getting as B plus C, C plus A plus B. Here again Q plus R plus P plus Q. Here Y plus Z plus X plus Y. So everything is twice, that is 2A, 2B plus 2C. Similarly 2P plus 2Q plus 2R. Here again 2X, 2Y plus 2Z. So we got it in such a way, 2A plus B, 2P plus 2C. So 2 into A plus B plus C, 2 into P plus Q plus R, 2 into X plus Y plus Z. So that I can take 2 out. So if I take the constant multiple 2 out, 2 into the determinant A plus B plus C, P plus Q plus R, X plus Y plus Z is got. The next thing, I have to make it here a single element like A, B, C, so that I am going to do R1 minus R2. If suppose I am subtracting this element by C plus A, C and A will get cancelled, B alone remains. That is what been done here. The next step, R1 tends to R1 minus R2. So A plus B plus C minus A. The next time, P plus Q plus R minus P. So R and P get cancelled, Q remains same. Here Z and X get cancelled, Y remains the same. So this is being done in the next step. R1 tends to R1 minus R2. Now our determinant will be B, Q, Y, C plus A, R plus P, Z plus X. The next step is, here we have A plus B, here we have B. Suppose I am subtracting A plus B minus B, then I will get a single element A. So that I am doing the operation R3 tends to R3 minus R1. So A plus B minus B, P plus Q minus Q, X plus Y minus Y. Now we are left out with A, P and X. So next we have to diminish this. Here we have A. So I will subtract this R2 minus R3. So R2 tends to R2 minus R3. If I do so, I will get C alone. R1 is as it is, R2 minus R3. C plus A minus A. A and A will get cancelled. Here again PP will get cancelled. XX get cancelled. So now we are arrived with 2 into determinant of B, Q, Y, C, R, Z, A, P, X. But in the question it has been 2 into A, B, C in such a way. The order is in such a way. So I am just interchanging the first row by second row, so that B will come here. Therefore, by the property, it is minus of the determinant. The next step is I am just interchanging the first row by the third row and the third row by first row. Again, by the property, you will get one more minus out, so that minus into minus will become plus. When I do so, I'll get it A, P, X, B, Q, Y, C, R, Z. 2 into this. So I have taken the LHS and proved to your RHS. The next problem, determinant 0A minus B minus A 0 minus C, B C 0 equal to 0. So this is a given determinant delta. Now minus is taken as a common factor from the first row, that is by the property minus of 0 minus A plus B. Now from second row again take minus as a common factor. So you will get again minus of A 0 C. So minus into minus will become plus. Now from the third row take minus as a common factor. So minus into minus it will be minus. So this is minus of determinant 0 minus A B A 0 C minus B minus C 0. Now what we are going to do is we are just interchanging the rows by column, that is transpose of this. If I take transpose of this, the determinant value remains the same. We have already seen by the property delta and the delta dash, that is our transpose is same. When I do so, my determinant will be minus 0 minus AB, A0 C is in the column and minus B minus C 0 in the next column. We will be getting like delta is equal to minus determinant of this. And this is nothing but our given determinant. Let us see that. Given determinant is this. Now I can replace in the place of that delta, the same determinant. So delta is equal to minus delta. Delta is equal to minus delta. When it comes to our RHS, delta plus delta is equal to 0. 2 delta is equal to 0. Therefore, delta is equal to 0. That is determinant equal to 0. The next question, determinant minus A square AB AC, BA minus B square BC, CB minus C square equal to, we have to show some value. So, first let us take the determinant. What I am going to do is, let me take A from this, and so A into determinant minus A, B and C. From the second row I will take B out. If I take so B, here A minus B and C. From the third row, let me take C out. So A, B, C is out here. So A, B and C. This is what the determinant. Now next I am going to do any two element of the row or column 0. Then let me find the determinant value. Here we have to give some value. We are not going to equate it to 0. So let me add these two rows. So A minus A plus A will be 0. B minus B will become 0. C plus D will be 2C. R1 tends to R1 plus R2. If I do so, minus A plus A, B minus B, C plus C. A minus B, C, A, B minus C. So now this two term is getting 0, 2C. Equal to ABC, determinant 0, 0, 2C, A minus BC, AB minus C. Now take the determinant. When I take the determinant, this term will become 0. That is equal to ABC. 0 into something will be the 0. Again minus 0 into the determinant is 0. The last term is plus 2C. So 2C into, leave this column and this row, will have A minus B, AB. A minus B, AB. Now simplify this. A, here we have 2 AB C square, 2 AB C square. When we find the determinant value, AB minus minus AB. So AB minus into minus plus 2AB. So 2AB, 2AB square 2AB, that is 4A square B square C square. The next question, determinant 1A A square 1B B square 1C C square equal to A minus B, B minus C, C minus A. So let us take the LHS and prove the RHS. Here again same, I will make two of the elements 0, and when I find the determinant, I will reduce the determinant values so that I can find the A minus B, B minus C, C minus A. The first operation is R2 tends to R2 minus R1. So we have the determinant. This is what our determinant, R2 minus R1. So 1 minus 1, 0. Next B minus A. Next B square minus A square. Next R3 tends to R3 minus R1. 1 minus 1, C minus A, C square minus A square. That is what written over here. Here I am taking the determinant value in the column wise. When I leave this row and this column, so I will have B minus A, B square minus A square, C minus A, C square minus A square. Next I will take 0 into, leave this row and this column. So 0 into anything, it will be 0 again. The third element plus 0 into, I will take this. When I take it so, 0 into anything, it will become 0. So when I do the determinant value in the column wise, I will get only the value of 1 into B minus A, B square minus A square, C minus A in such a way. I will write B square minus A square as B plus A, B minus A. It is a square minus B square formula. A square minus B square equal to A plus B into A minus B. By using this formula, I can write this B plus A into B minus A. Again, C square minus A can be written as C plus A into C minus A. That is what been written here. So when I replaced it, I have B minus A common in the first row. I will take B minus A out and I will write it 1 B plus A. From the second row, I will take C minus A out. C minus A into 1 C plus A is been written. So B minus A, C minus A. Now our determinant 3 by 3 is reduced to a 2 by 2. Now this is equal to C plus A minus B plus A. See, now this is equal to B minus A into C minus A into C plus A minus B minus A. So C, A will get cancelled. We have B minus A, C minus A, C minus B. But this is not our result. We have A minus B. So A minus B, I'll take minus out, A minus B. Next I need B minus C. So from this element I'll take minus again out. So B minus C. The next element C minus A. This minus and minus will become plus. So that my result is A minus B into B minus C into C minus A. This is what we need to prove. We have proved it. The next question. Determinant 1, 1, 1, A, B, C, A cube, B cube, C cube is equal to A minus B, B minus C, C minus C, A plus B plus C. So this is again similar like the previous one. I'll make these two elements 0 by doing the operation C2 minus C1, C3 minus C1. Then if I find the determinant value, it will be reduced to 2 by 2 so that I can easily find the value this. So it has been taken C2 minus C1 for the C2 and C3 tends to C3 minus C1. So C2 is 1 minus 1, 0, B minus A, C minus A, B cube minus A cube, C cube minus A cube. The first operation is C2 minus C1. 1 minus 1, B minus A, B cube minus A cube. So C2 is this. Now C3 is C3 minus C1. 1 minus 1, 0, C minus A, C cube minus A cube. That is what written here. The next step is now find the determinant value along the row wise. If I do so, 1 into b minus a, c minus a, b cube minus a cube, c cube minus a cube. These two terms 0. 0 into anything, it will become 0. Next thing is, now we have a cube minus b cube format. We should know what is a cube minus b cube formula. A cube minus b cube is equal to a minus b into a square plus ab plus b square. We are going to apply this formula here. On applying a minus b whole cube formula, we get it like b minus a into b square plus ab plus a square. For c cube minus a cube, c minus a into c square plus ca plus a square. Now find the determinant value of this. From the first column, b minus a is common. So let me take b minus a out and write 1 b square plus ab plus a square. From the second column, c minus a is common. So I'll take c minus a out and I'll write 1 c square plus ac plus a square. Now I got it. B minus a into c minus a, determinant 1 b square plus ab plus a square, c square plus ac plus a square. Now expand this. B minus a, c minus a into 1 into this c square plus ac plus a square minus b square plus ab plus a square. It is equal to b minus a, c minus a, c square plus ac plus a square minus b square plus ab plus a square. Now send this minus inside. So minus b square minus ab minus a square. So a square minus a square will get cancelled. We get c square plus ac minus b square minus ab. So now I'll write c square minus b square plus ac minus ab. So that c square minus b square, I'll apply the formula. That is c plus b into c minus b. So b minus a, c minus a into c square minus b square plus ac minus ab. B minus a into c minus a, c square minus b square is written as c plus b, c minus a, c minus b plus a into c minus b. A is common in these two terms, so we have taken a outside. Now from these two terms, c minus b is common, so let us take c minus b out, so that we'll be getting a plus b plus c. B minus a, c minus a, c minus b into a plus b plus c. Now our result is a minus b into b minus c into c minus c. So that from the first term I'll take minus out, a minus b. This c minus c as it is. From the third term I'll take minus out, b minus c, a plus b plus c. So minus into minus, it will become plus. So that my result will be a minus b, b minus c, c minus a into a plus b plus c. LHS is taken, RHS is proved. The next question, x square yz, y square zx, zx square z square xy is equal to x minus y minus z minus x, xy plus yz plus zx. I'll multiply the first row by x and I'll divide by x so that it will balance. X by x will be 1 again, so that I'm just multiplying and dividing it by x. In the second row I'll multiply y, because we have x, z, I need y. So I'll multiply y and divide by y. Same again here, multiply z and divide by z. The row 3 is multiplied by z and divided by z. That is what written, multiply and divide x for the row 1, y for the row 2, z for the row 3. It has been done here. X into x by x, x into x by x, x square into x by x, x y z by x. Again y into y by y, y square into y by y, zx y by y, z into z by y, z square into z by y, x y z by z. Now in first row I'll take 1 by x alone out. From the second row I'll take 1 by y. From the third row I'll take 1 by z outside. So if I take only the denominator from the row, the numerator will be same, x square, x cube, xyz. Okay. From the second row, I'll take 1 by y out. I'll be having y square, y cube, xyz. From the third row, I'll take 1 by z out, z square, z cube, xyz in the numerator. It remains the same. From the last column, xyz is common, so that I'll take xyz outside. So xyz by xyz. Now this third column, we have 1, 1, 1. So that I'll make any two of the elements 0, so that I can find the determinant value with the help of third column. Will be easily able to find by the diminishing to the 2 by 2 determinant. That's what done here. R2 tends to R2 minus R1. R2 minus R1. That is y square minus x square, y cube minus x cube, 1 minus 1, 0. R3 again. R3 minus R1. Z square minus x square, z cube minus x cube, 1 minus 1, 0. So it has been written here. Now these two terms are getting 0. When you take the column 3 as the determinant, finding the determinant value, 1 into leave this column and this row will have y square minus x square, y cube minus x cube, z square minus x square, z cube minus x cube. When we do it 0 into anything, it will become 0. Again 0 into anything, it will become 0. So y square minus x square, I can write it as y plus x, y minus x. Y cube minus x cube can be written as a minus b into a square plus ab plus b square. That formula is applied here. Y minus x, y square plus yx plus x square. Same again for z cube minus x square. This I can write it as z plus x into z minus x. Here a cube minus b cube, a minus b, z minus x into a square, z square plus x square plus zx. Now from the first row, y minus x is common. So let us take y minus x out. From the second row, z minus x is common. So let us take z minus x out. So the remaining elements are y plus x, y square plus yx plus x square. In the second row, z plus x, z square plus zx plus x square is left out. Now find the determinant value. Y minus x, z minus x. Now y plus x into z square plus zx plus x square minus z plus x into y square plus yx plus x square. Now multiply these two terms. Y into the whole term, y into z square. Next y into zx, that is xyz, y into x square y. Next x into z square. Next x into zx, so x square z. X into x square, that is x cube. Minus, we have to multiply these two terms. Now z into y square, z into yx, that is xyz, z into x square z, plus x into all these terms, x into y square plus x into yx, that is x square y, plus x into x square x cube. Now simplify this term. Yz square plus xyz plus x square y plus xz square plus x square z plus x cube. Send this minus inside. Minus zy square minus xyz minus x square z minus xy square minus x square y minus x cube. So that xyz cancel. X square y get cancel. X square z cancel. X cube and x cube get cancelled. The left out elements are yz square, xz square, minus zy square, minus xy square. Now from these two terms, yz is taken out. So z minus y will be out. From these two terms, x is common. Let me take x out. So z square minus y square. Now this again I'll replace like z plus y into z minus y. So next term yz, z minus y plus x into, the rest of the elements will be coming as it is. Only changes in the z square minus y square is z plus y into z minus y. Now from these two terms z minus y is common. So z minus y is taken out. So if I take z minus out, it will come here. Y minus x, z minus x, z minus y into whatever yz plus x into z plus y. Now simplify this. Yz, xz plus xy is here. So the three term we have got it. The rest of the here is y minus x, z minus x, z minus y. In the equation we have x minus y, so that I'll take minus out. Minus of x minus y. Here z minus x is as it is. I need y minus z, so I'll take minus out. Y minus z into xy, yz plus xz. So minus into minus will become plus x minus y minus z, z minus x, xy plus yz plus zx. Hence we have proved the LHS is equal to RHS. Next question. Determinant of x plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4 equal to 5x plus 4 into 4 minus x the whole square. So we have to prove this. Let us take the LHS. See here, if I add by column wise x plus 2x plus 2x, that is I'll get 5x plus 4. Here again 5x plus 4. Here again 5x plus 4. We'll be getting the one of the term. Or else you can add it by row wise. Either you can do it by column wise or else by row wise. So even if I do it by column wise, 2x plus 2x plus x plus 4 is 5x plus 4. Here I have done with column wise. C1 tends to C1 plus C2 plus C3. So that I have got 5x plus 4, 5x plus 4, 5x plus 4. The next two columns remains as it is. Since 5x plus 4 is a common multiple, I'll take it out. 1, 1, 1. Now let us make any of the two elements 0, so that our determinant value will be reduced to 2 by 2 form. So R2 tends to R2 minus R1 and R3 tends to R3 minus R1. I am doing it. R2 minus R1, x plus 4 minus 2x, that is x plus 4 minus 2x is minus x plus 4. Here a 2x minus 2x, so it will become 0. R3 tends to R3 minus R1, 1 minus 1 0, 2x minus 2x again 0, x plus 4 minus 2x, so minus x plus 4. Now let us find the determinant value. We have diminished this. Along the column wise I am doing it. If I do so, 1 into, leave this row and this column, I will be getting minus x plus 4 0, 0 minus x plus 4. Now find the determinant value. Minus x plus 4 into minus x plus 4 minus 0. That is nothing but 4 minus x the whole square. 5x plus 4 into 4 minus x the whole square. We have proved it. The next problem. Determinant y plus k, y plus k, y plus k equal to k square into 3y plus k. This is again the similar method we have followed in the previous problem. See, if we add these three columns, y plus y, we'll get 3y plus k. Suppose we are adding by row wise, y plus y will get 3y plus k. Either you can do it by row or by column. So you get 3y plus k, 3y plus k, 3y plus k. The remaining element in the column 2, column 3 remains as it is. 3y plus k is common. Let us take 3y plus k out. Determinant 1y plus k, y plus k. The next step is what? We have to make these two elements 0. So R2 tends to R2 minus R1. R3 tends to R3 minus R1. This has been done in the next step. So R2 minus R1, 1 minus 1, 0. Y plus k minus y. Y will get cancelled. K is remained. Y minus y is 0. Next R3 minus R1. 1 minus 1, 0. Y minus y, 0. Y plus k minus y. So y will get cancelled. K remains as it is. Now by the column wise take the determinant value. If I do so, I'll get it 3y plus k, determinant k 0 0 k. So find the determinant value k into k square. So we have proved LHS is equal to RHS.